Define the term conservative force. A conservative force is a force for which work done on an object is independent a force for which the work done on an object is independent of the path taken. Right. Name the conservative force acting on the object. Name the conservative force acting on the object. Right, in this case, an object slides down a rough, curved track. Graph tells you that there is friction. Passes point A, which is above 1.5, the object at point B. So they name the conservative force. One of the conservative forces here is the force of gravity. So 5.3 is mechanical energy conserved as the object slides from A to B. I mean, they just said that A to B, there is friction. So is mechanical energy conserved as the object slide from A to B? No, it is not. Right, then they say number 5.4, calculate the gravitational potential of the object when it reaches point A. Gravitational potential energy 5.4 EP is equals to mgh. So we take the mass of the object 1,8 multiplied by 9.8 and the height of the ground, which is 1,5. This requires the use of our calculator. So we use our calculator 1,8 multiplied by 9.8 multiplied by 1,5. It should give us 26,46 joules of energy. Then we go to 5.5. Using energy principles, calculate the work done by friction on the object as it slides from point A to point B. Right, using energy principle, what we can use is we can also say the total mechanical energy it's having at point A, we compare it to total mechanical energy at point B, and the difference will give us it should give us the work done by friction. Right. Another way would be to say work done by a non-conservative force is equal to change in kinetic energy plus change in potential energy. In this case, that means I'm going to say half mass V final squared minus V initial squared plus the change in potential energy, in this case, which is mg times final height minus initial height. That will be the work done by friction. So we come here, we say half of the mass, which is our mass, which is 1,8, multiplied by the final velocity there, which is 4 squared minus the initial velocity 0.95 squared, plus the mass of this object here, 1,8 multiplied by 9.8, final height, which is 0 minus the initial height, 1,5. Bring back the calculator. 0.5, close bracket, 0.8, 1.8, close that bracket, 4 squared minus 0.95 squared, close that bracket, and we add it to the following 1.8, 9.8, and the difference in height, which is 0 minus the 1.5. Yet our answer is minus 12,87. This is the work done by frictional force. Then they say surface BC in the diagram above is frictionless. When they say frictionless, it means there is no friction. And they say what is the value of the net work done on the object as it slides from point A to point C. Right. We must draw the flipboard diagram to sort of explain it. So there's the force of gravity and there's the normal force. Now there is no friction. I don't have a force there. There's no force acting on it here. So it means the net force here is 0. Therefore, the net work done on the object is also going to be 0 joules of energy, because net work is the net force times the displacement. In this case, since we don't have a force acting on the object, then there's going to be 0 work done on the object from point B to point C.